Welcome to the Max Planck Institute for Dynamics and Self-Organization here in Göttingen. As you see behind me is the Max Planck Institute and also the experimental hall. In the experimental hall we have the Göttingen turbulence facility. The trick of that facility is to use compressed sulfur hexafluoride at high pressures to get high Rayleigh and Reynolds number. So these are the storage tanks. Over here we have 5 of them, and these storage tanks, currently we have the 12-ton sulfur hexafluoride. As you will see inside, we don't have any gas right now in use as the experiment is apart. And then over here we have the liquefier. So this is the liquefaction unit. In that unit we can pump the SH6 out of the tunnel. On the other side we have the big wind tunnel and also the U-boat. And in both of them we can decrease the pressure to 1 millibar, and therefore we have very, very little gas left when we are done with the experiment. We are now inside the experimental hall. Over here we see the U-boat. It's the blue pressure vessel over here. It's 2.5 meters in diameter. It's 5 meters long, and it has a 4-meter turret, which you will see in a moment. In here we house the convection experiment, and of course when the door is closed, then we can pressurize this vessel up to very high pressures. And all the details will now be described to you by Xiaozhou He, who is the first author of our paper, and he will now tell you the details of the experiment.
So this is the dome of the U-boat. We use a crane to put the sail in, and after that we seal the dome with the screws.
Now I'm standing inside the U-boat. This is a convection cell with a aspect ratio equal to 1. We connect the water pipe and the cables outside of the U-boat, and we run the experiment remotely. Now the cell has been packed up, and I will use pictures to show the construction details.
We used 2 convection cells in the experiment. They have an aspect ratio equal to 1 and 1/2. The metal plate has a mirror finish. On the back side of the bottom plate, we glued heaters to provide uniform heat flux. For the top plate, there is a cooling water channels on the back side. We used the circulating water to maintain a constant temperature. Close to the top and bottom plates, we installed several thermal shields with constant temperature. We also used a large thermal shield to cover the sidewall. Temperature on each of them was regulated individually, and the resolution is 10 millikelvin. By this means, the convection flow inside of the cell is completely insulated from surrounding temperature fluctuations. After assembled, we put the 2 convection cells into the U-boat and measured the normalized heat flux, namely the Nusselt number as a different Rayleigh number, at the same time. The results for the aspect ratio 1 cell are shown in color. We can see there is a transition at Rayleigh number around 2 times 10 to the 13. After this transition, the Nusselt number behaves similar to that was found in the aspect ratio 1/2 cell, the black symbols. We interpret this observation as the onset of the transition to the ultimate state of Rayleigh Bénard convection. Our results also suggest that the ultimate state transition is universal and independent of the aspect ratio.